Okay, so in this video we're going to now talk about microphones. Okay, and just as loudspeakers were something that came out of our study of the motor effect, microphones are something that come out of a similar study of the generator effect. Okay, so the generator effect is basically the motor effect in reverse. With a motor effect, we start with a current and a magnetic field, and we get a force that produces movement. But with the generator effect, instead, we start with movement and a magnetic field, and we induce or produce electricity. Okay, so simple demonstration of this would be if we had a wire and we move that wire between the north pole and the south pole of two magnets. If I was just to move that wire down, if I had an ammeter connected to that wire, it would, if it was sensitive enough, move to one side, showing that there was a potential difference being induced, and because I've got a complete circuit, that potential difference would then make a current flow in the circuit. Okay, and just as with the motor effect, the direction of everything is important. If I move the wire up instead of down, the current would be in the opposite direction. If I reverse the north pole and the south pole of the magnet, the current would be in the opposite direction. Okay, but the generator effect is basically this. If I have a wire or some kind of conductor and I move it through a magnetic field, that induces a potential difference, which in turn, if there's a complete circuit, induces a current. Okay, so let's go back to our diagram here. Now, this was a diagram I used in a previous video for a loudspeaker, but a microphone is basically just a loudspeaker in reverse. Okay, so there are lots of different microphones, but we're just going to consider this as a simple example, and essentially it really is a loudspeaker in reverse. So with the loudspeaker, we provided the signal that made the coil and the cone move in and out to produce the sound waves. Okay, what we're basically doing here with the microphone is the reverse process. We have a source of sound here. This could be somebody singing, talking, playing a musical instrument, any of those things. Okay, that will create sound waves that travel through the air, and when they reach the cone, they will start the cone vibrating. Okay, and as the cone vibrates, that moves the coil in and out. And remember, the coil is sat around this north pole. That will start the coil vibrating, moving in and out in this magnetic field here. And what that does is that induces a potential difference. Okay, so here, rather than starting with an electrical signal and producing a sound wave, it's really the exact opposite process. We start off with a sound wave that vibrates the cone in and out, that moves this coil in and out of the magnetic field, which then induces the electrical signal. Now that electrical signal could then go off and be amplified across some sort of PA system, or it could be recorded, put onto a compact disc, or turned into an MP3 file. Okay, but it really is just the opposite process to what we looked at before.